Alright, we are at Go To Math, working on some calculus problems, and we're actually in the section Infinite Limits, and here at button number 1. Okay, so let's bring up the whiteboard and erase that. I'm not sure what that was all about. Okay, so we got k of x, and of course, I don't think I mentioned what we're doing with this, but we're finding vertical asymptotes. And to find a vertical asymptote, you just take the denominator and you set it equal to 0 and solve for x. Right? Well, if we square root both sides, like you're supposed to do, you get plus or minus the square root of 0, and of course that's nothing more than 0. So our vertical asymptote is x is equal to 0. Now let me just sketch up maybe what this graph probably looks like. It's going to look something like this. Okay. Now what about this side of the graph? Well, we're not going to get any negative y values, which would appear down here in quadrant 3, because every time we square a negative value it becomes positive. So this entire number here will always be positive. Alright, is always going to end up being positive. But as we go out in this direction, as that negative number gets, I guess you'd say smaller, but larger, anyway, the number gets larger. It's a negative number that's getting larger. Anyway, this whole thing here is approaching 0. So it's going to look something like this right here. Alright? Now, the vertical asymptote, as you can see, is the y-axis, or when x is equal to 0. Now, I'm going to also add, what if we were to find this, and we talked about this in the previous section, these left and right handed limits. Now we're coming in from the left hand side approaching 0. What is happening as we get closer and closer to 0 coming in from the left? What is happening to our y value? Well, it's increasing quickly, isn't it? So this is technically going to positive infinity, and if we did x is going to 0 from the right of 3 over x squared, okay, coming in from this direction, it's also going to infinity. There you go. It's going to infinity. I guess we could say that the limit as x approaches 0, that'd be coming in from the left from the right. Even though our limit, this thing is supposed to be equal to a real number, but we could say this because this gives us the behavior. It gives us the behavior of the graph. And the behavior of the graph says that, as you can see, coming in from the left and from the right, that behavior is going to infinity. I guess that's what you could say. However, some instructors don't like you to write the limit like this, but I've seen it in lots of textbooks where it is actually written like this, but it does need to state that this describes the behavior of the graph right here. Alright. Okay, so vertical asymptotes, you just set the denominator equal to 0 and find the solution set x. However, if we took this number and plugged it into the numerator and got 0 out up here also, that means that this is not a vertical asymptote, but it's probably got a hole. There's a missing point in the graph when you get 0 over 0. So we've got to be careful about that. Just the denominator, okay? Just the denominator must be 0. And of course we don't have to worry about it in this particular function here. Let's bring up the website. Okay, this is the chat box. You can chat live with me if I'm on here. That's if I'm on here, so who knows if I'm going to be on there or not. You want to check the message up there.